Alright, hello everyone. So today we will be discussing the entire chapter of electricity, starting off with static electricity. Now, I'm not sure about Janije. The normal state of an atom, which is a neutral substance, has an equal number of protons and electrons. In charging by friction, some electron from one object is moved to another object. The object gaining electrons becomes a negative charge, whereas the object losing electrons becomes a positive charge, as you can see from the diagram. Electric charge is transfer of electrons, basically. If an object has more electrons than protons, it's negatively charged, and if an object has more protons than electrons, it is positively charged. Let's say we are comparing these two spheres together. If, let's say, these two spheres are in front of each other, and the positive sphere, what happened to the positive one is that electrons was transferred to the other sphere. So this sphere became positive and the other became negative. If you are asking a question that how is a substance positively charged, you will be saying that the electrons moved from this object to another object. Thus, it's positively charged. Protons will never move. Remember this, and electrons will move. Okay. However, you can ask questions like, what will happen if two negative charges are pulled together? They will never be attracted. They will be repelled. Next up is electrostatic induction. Induction is the passing of electricity from one object to another without touching them. Electrostatic induction occurs mainly in metals and conductors. As you can see, the positive charge gets uniformly distributed on the surface of the conductor. By this process, the neutral conducting sphere becomes positively charged because, as you can see, the electrons are being transferred. Okay. The distribution of positive charges is not uniform for arbitrary shaped conductors. Now, for example, over here, you can see that this sphere is connected to a circuit, right? It's basically an earth wire, which we will be learning about very soon. The earth wire actually creates an alternate pathway for the circuit. Charges are concentrated where the surface is sharply curved, okay? And a conductor having a sharp point has the highest concentration of charge. Example, sharp points can have a very high charge density. Next up is a question. This may come in your exams, which is, what is electric current? It is the region of space where a small positive charge experiences an electric force. The direction of field is defined as the direction of the force on a small positive charge. And if you are asked to draw it, you will be seeing that the positive charges are like this. They will be attracting the electrons and it will be moving away, like the arrows will be facing forwards, whereas in a negative charge it will be facing inwards. All right, okay, so that's the thing. Okay, next up, let's learn about yeah, now it's good. Okay. Right, next up you will see the field. This is the field that you need to know. And as you can see, the negative charge, when two negative charges are put together, this diagram is like this, and when two positive are put together, it's like this. Alright, next up, conductors and insulators. Conductivity is the ability of materials to allow electrons to move freely. Materials that hold on to their electrons and do not allow them to move easily are called electrical insulators. Insulators such as plastics and metal. Plastics, they do not allow electrons to move. Materials that allow electrons to change positions are called conductors. Right, as you can see, here are some examples. Over here is an insulator, and over here are conductors. This is a metal, and this is a copper wire. Copper is a very good conductor of electricity. Now, in insulators, the electrons are tightly connected to the nuclei, so they resist movement. And in conductors, the conductors are not as tightly connected to the nuclei, so therefore they move away from the nuclei because of charges. Okay. Now, laws of electric charges: like charges repel, opposite charges attract. Protons are positively charged, electrons are negatively charged, of course. Without these attractions, electrons would be held in their nuclei. Now let's learn about the lightning conductor, which is a diagram which may come in your exams, which is, as you can see, there's a storm cloud, and this is a stream of positive ions, and there is a spike. Over here you can see that we have been given a definition that places with a very sharp point has a lot of electric charge, and that exactly is being shown over here. Okay, this is what happens in buildings. Like, they put antennas or they put lightning conductors on top of the building so that whenever there's a thunderstorm, the thunder, it doesn't strike the building, but it strikes the rod, right? and this metal plate is gonna be it's connected to the ground, okay, and electrons will be repelled to the earth, okay. The negatively charged cloud induces a positive charge on the spike of the lightning conductor. Air is an insulator of electricity, but when the voltage of the charged cloud is very high and the damped air is mixed, its insulating property is broken and a huge charge is conducted through air, which you can see from the diagram. Yep, there's a stream of positive charges. Okay. During this conduction, immense heat with a large spark occurs, which is called the lightning flash. The lightning is above the highest part of the building, so it accepts any discharge earlier than the building. Mane the highest point it's the highest point, right? So it will always be attracted to the highest point, and it will make sure that the building doesn't get struck with the lightning spell. Earthing. The earthing or grounding system is the heart of it's the heart of any electrical installation. The safety of the people and equipment connected to it depends on its design, its execution, and its condition. As the excess current will flow to earth, preventing personal injury or failure of the electrical components connected to it. Earthing is one of the most important things that you need to know if you know about circuits and electrical appliances. Earthing ছাড়া কিন্তু আমরা কারেন্টের সাথে বাড়ি খেলে আমরা মারা যেতে পারি. But these earthing systems make sure that all electrical appliances are safely used. Now during lightning, what happens? During lightning, the surrounding air temperature will rise drastically, which causes the molecules to expand at a very high rate. And after the lightning stops, then the temperatures fall at a very high rate and cause the molecules to contract. This sudden expansion and contraction will cause the rumbling sound. Now let's come to part 2 of the chapter, which is circuits. Now this is a question that will come in your exam. What is electric current? It is the rate of flow of charges. তোমাকে যদি ask করো what is electric current, মুখস্থ করে বলবা it is the rate of flow of charges, okay? Electric current is the rate of flow of charge, okay? Current is defined as the rate at which charge flows through a surface, which is the same thing. I is equal to Q by T, right? This is the formula for charges as well, which is also the formula of current. Q is coulombs, which is charge, and seconds is time. So I is equal to Q by T, and current will be measured in the unit amperes or amps, right? The current is in the same direction as the flow of positive charge for this course, okay? As you can see, in the circuit there is a cell. আমরা এই ছোট পার্টটাকে cell বলি, and the direction that the current is flowing through, this is the direction of the current, which is the positive charge. And remember that the note that I stands for electricity. Current is also written as the formula charge by time, or I is equal to Q by T. And you can also write charge is equal to IT. Charge is equal to current into time. The unit of current is amperes, so charge is measured in coulombs. Now 1 ampere can also be written as 1 coulomb per 1 second. 10 amps can be written as 10 coulombs per second. That's the definition. Current direction is the movement of positive charges. Conventional current is another thing that you need to know. It is the movement of the direction of negative charges. Potential difference between 2 points is defined as the work done to move 1 coulomb of charge between the points. Potential difference is equal to work done by charge moved, or potential difference is equal to work divided by Q, or yeah. Number 2, potential difference is equal to energy transferred by charge, or PD is equal to E by Q, or V is equal to E by Q. This is another definition. And for electromotive force, but before we come to electromotive force, we need to know some circuit symbols, which will be very important. Firstly, you need to see that this is a lamp, okay? Let's draw this for our briefing, okay? So here's what I do. I go to whiteboard. I hope you can see. I hope the screen is not rotated. So let's say, guys, this is called a cell, okay? This is the positive and this is the negative terminal. Remember this. And when we make it like this becomes a battery, okay? Negative and positive, all right? This is a battery and the previous was cell, which you need to know very importantly. Next up is a lamp, and the lamp is basically any electrical appliance in a circuit, okay? Now let's move on. Over here you can see in a question যখন বলবে একটা open switch, it will be like this. Open switch এ কিন্তু কখনো current flow করে না. Closed switch is when the current is being flown, okay? This is a lamp, this is a resistor. Resistor is something যে তোমার সার্কিটটাকে বাধা দেয়, সেই কারেন্টটাকে ডিক্রিজ করে ট্রাই করে, it tries to decrease the current. And variable resistor is another thing. There is thermistor, okay? There is ammeter for current measurement, and voltmeter for voltage measurement. There is a light dependent resistor or LDR. There is a diode. There is an LED. There is a cell and battery, and of course there's a fuse. We will be learning about all of these electrical appliances by today, and if it's not in this video, you can go to the next video to learn more. Next is a very important O-level syllabus question, which is what is electromotive force? It is the transfer of energy per coulomb of charge. Remember this, guys. Formula is equal to EMF is equal to work done by charge, okay? And the unit of EMF will be in volts. Next up is Ohm's law. Ohm's law says that current in a conductor is directly proportional to the potential difference between points of the conductor. Okay, this means that when current increases, the voltage will also increase. And V is equal to IR, where R is the resistance of the conductor, and I is proportional to voltage. Like if voltage increases, current will also increase. This is what Ohm's law is gonna say. Resistance R is defined as the restriction of electron flow. It is due to the interactions that occur at our atomic scale. For example, as electrons move through a conductor, they are attracted to the protons on the nucleus of the conductor itself. This attraction doesn't stop the flow of electrons, just slow them a bit and cause the system to waste energy. Okay, so this means that electrical resistance cannot be equal, so the current, it doesn't flow more than it's required. Okay, resistance is equal to voltage by current. Factors affecting resistance are, if you increase the cross-sectional area, and it will be decreasing the resistance. Let's take a let's do a drawing so that I can explain this to you. Factors affecting resistance. First, we see what is cross-sectional area. Let's say this is one pipe. Okay, this is one pipe, and this is another pipe. Okay, and now let's say we have a few bodyguards. Let's say this is X and this is X. Okay, and over here this is X and this is X. And let's say over here we have current. Okay, this is current which is passing through. Let's also define this as two defenders protecting a football goalpost. ঠিক আছে, এখন let's say এখান থেকে the strikers are from the opposing team, they're shooting the ball, but the two defenders, they are very fat and the goalpost is very small. This will cause the goal not to get inside. So if you decrease the cross-sectional area, it will increase the resistance. Okay, but if you increase the surface area or the cross-sectional area, it will decrease resistance. Okay, resistance is decreased and resistance increase in cross-sectional area. That means the ball can pass through or the current can pass through. Get it? This is what we are learning here. All right, next up, question number, which is, oh yeah, we have to know more, which is what is the length of the wire? If you increase the length of the wire, it will increase resistance. Temperature will increase resistance if it's a metal conductor, and it will decrease if it's a semiconductor. And remember, at low temperature, semiconductors behave like insulators, as they do not have free electrons and thus high resistance. When the temperature rises, that number of free electrons increases, so its conductivity increases. Now, here's a question. In 2 minutes, 3 amperes of current passes. What is the charge? Answer, Q is equal to IT. 3 into 120 is 360 coulombs. Question number 2. Current 5 amperes for 3 hours. What is the charge? 5 into 60 into 60, which is where we converted time into seconds. 3 hours can be written as 3 into 60 into 60 into the current 5, which is Q is equal to IT, which is 54,000 coulombs. Okay, and we should also remember that in 1 coulomb charge there is 6.25 into 10 to the power 28 electrons present, which is like quadrillions and quintillions. That's a huge ass number. Current direction is equal to the opposite of electron direction, which is another thing you need to know. And in electrical circuit, these are the symbols and everything, which I repeated over here again. Okay, here are some formulas that you need to memorize. Number 1, V is equal to IR. Number 2, I is equal to V by R. And number 3, R is equal to V by I. Formulas for charge, I is equal to Q by T, Q is equal to IT, and 1 amps is equal to 1 coulomb per second. Formulas with power, which may come if you're in class 9, but if you're in class 8, this will not come most likely, but if it does, it's good for you to memorize. Number 1, power is equal to V by I, or voltage into current. P is equal to I squared R, or current into resistance. Next, power is equal to V squared by R. Okay, formula for energy, E is equal to VIT, E is equal to VQ, and Q is equal to IT. Okay, now VI jehuto, we can also write this as E is equal to the power into time. Okay, because P is equal to VI. We can also write E is equal to PT. Right? That's all. We will be learning more about circuits and current and electricity in our next video. Hope you all enjoyed this video, and best of luck, everyone.